morning. Today we are going to cover 4.2, which is exponential equations. There are two types we're going to look at solving. Remember, you need to keep your answers in reduced fractions when possible. If a decimal cannot be turned into a fraction, you can round it to 3 decimal places. The first type of exponential equations we're going to look at is where both sides can be written in the same base. So if I look at A, my common base is 2. So that means the left side is 2 to the 2x plus 14. And 64 can be rewritten as 2 to the 6th. Since the bases are equal, I can now set my exponents equal. So I'm going to say 2x plus 14 equals 6. Subtract 14 from both sides and divide by 2. The answer is x equals 4. Now if I look at B, 32 cannot be written as a base of 4. 4 to some power does not get me 32. So in some cases, I need to rewrite both sides of the equation using a common base. In this case, I'm going to rewrite them both as a base of 2. So 4 is 2 squared. Bring along the 3x. 32 is 2 to the 5th. Bring along the x plus 1. Again, my bases are equal, so I can set my exponents equal. Remember, when we raise a power to a power, we multiply. So on the left, I have 2 times 3x. And on the right, I have 5 times x plus 1. So that gives me 6x. Over on the other side, I need to distribute the 5 to both of them, not just the x. And I'll subtract 5x from both sides, so I get x equals 5. For C, my common base is 3, so the left side is fine. 3 raised to the 2x plus 5. My right-hand side, I need to write 1/9 is really, remember, 3 to the negative 2. 9 is 3 squared. I need to make it a negative to bring it up into the numerator position. And the x minus 1. Again, now that I have same bases, I set my exponents equal. So I have 2x plus 5 equals negative 2 times x minus 1. Make sure you put the parentheses because we need to remember to distribute it. I'm going to add 2x to both sides. And subtract 5. So x equals negative 3/4. Okay, the last one of type 1. Now you'll notice I have 2 things on the left I need to rewrite and just 1 thing on the right. My common base for all of these is 5. So the first one, 25 is 5 squared. Bring down the times sign. 1 over 125 is 5 to the negative 3. Bring down the x plus 4. And 3,125 is 5 to the 5th. Remember, square root is raising it to the 1/2 power. So now all my bases are the same. I'm going to take care of the exponents. I bring down the 2. This times needs to come down as a plus, because remember, when we multiply exponents with the same, or when we multiply numbers with the same base, we add their exponents. And power to a power, I multiply. And the same over here, power to a power, I multiply. So I'm going to distribute the -3. Combine like terms. Now if you don't like dealing with fractions, I can multiply everything by 2 and then I don't have to worry about it until the end. So I'm going to do -6x minus 20 equals 5. So I can add 20 to both sides and divide. So x equals -25, 6. From here, now we're going to move on to type 2. So again, type 1 was where I could rewrite them all using the same base. Type 2 is that I can't, and so we're going to have to take the log of both sides in order to solve them. So first thing I have to do for exponential equations is get it to where you just have an exponential equals everything else. So I need to have the exponential isolated, which I do in this case. So as soon as I do that, I'm going to take the log of both sides. So I write log of 3 raised to 2x minus 1 equals log of 7. Now this is log base 10 because I'm going to use the log button in my calculator. So why does taking the log of both sides help me? It allows me to move this exponent to the front. So now I really have 2x minus 1 times the log of 3 equals log of 7. I'm going to go ahead and divide both sides by log of 3. When I do this, those cancel out. My logs do not cancel out on this side. So what I'm doing in my calculator is I'm typing log 7 divided by log 3. Make sure to close your parentheses, otherwise it's going to come out incorrect, or use the fraction bar, either way. When I do that, I get 2x minus 1 equals a really long decimal. I am going to keep that decimal in my calculator and use the answer feature to help me solve it, because I don't want to round until the end. If I round before, my answer could be a little off in the end. I'm going to add 1 to both sides. So in my calculator, I just type plus 1 and divide by 2. And now I can round to 3 decimal places because I am finished with the problem. If we look at B, B is not isolated yet. I need to get the 4 to the x all by itself and everything else to the other side. So first thing I need to do is I need to subtract 11. Now I'm going to divide by 3. And now I need to take the log of both sides. So I have log of 4 to the x equals log of -3. This exponent gets moved out front. So it's x log of 4 equals log of -3. Once I have it to this point, I could go ahead and divide by log of 4. The problem is you cannot take the log of a negative number. It doesn't work. If you type log -3 in your calculator, you will get an error message. Okay, think about when we graphed them. It didn't go to the left of 0. So there were no logs of negative numbers unless I translated it. Since this is not possible, my answer is no solution. Okay, on to C. Again, my exponential is isolated, so I'm going to take the log of both sides. I'm going to move my exponent out front. I'm going to divide both sides by log of 3. Again, make sure you keep that full decimal in your calculator. So I get 5x minus 3 equals 2.524. I'm going to add 3 to both sides. And divide by 5. And now since I'm done, I can go ahead and round. From here, we have compound interest to talk about. And then we are going to be done for today. So today we're going to be talking about compound interest. We are going to hold off on compounded continuously because that involves E. We're just going to deal with the compound interest formula over there. Hopefully you have seen this before. But now we're going to figure out how could we solve for time without just guessing and checking. So it says John invested $500 into an account with an interest rate of 3% that is compounded quarterly. So remember, quarterly means 4. How long will it take for his investment to double? So if I want to know how long it would take to double 500, that means my new amount would be 1,000 equals my original amount times 1 plus my interest rate divided by 4, because it's 4 times a year, all raised to the 4t. So I'm going to go ahead and divide by 500. I get 2 equals. I'm also going to write the full decimal of what is in parentheses. 1.0075 raised to the 4t. To solve an exponential, we are going to take the log of both sides. So it's log of 2 equals and remember, when I take the log of both sides, I can move my exponent to the front. So I'm going to do that all in one step. So it's 4t log of 1.0075. So if I want to isolate, I'm going to divide by the log. Remember, I'm moving everything away from t. So I end up with 4t equals 92.7658. I'm going to keep that in my calculator. I'm going to go ahead and divide. And when I'm talking time, I can go ahead and round to one decimal place. So it's 23.2 years. So in other words, if he adds no money to this and takes no money out, it will take 23 years plus a couple months, or a few months, to double from 500 to 1,000. Let's look at B. Carol invested $800 into an account that is compounded monthly. Remember, that is 12. Her investment after 5 years accrued to 1,107. What is her interest rate? So my final amount is 1,107 equals 800 times 1 plus r over 12, all raised to the 12 times 5, because it took me 5 years. So I'm going to go ahead and divide by 800. So I get 1.38375. Again, I'm going to keep in my calculator, and I have 1 plus r over 12, all raised to the 60th. So to undo that, I have to take the 60th root. Okay, this is going to be a decimal. That's fine. Leave it in your calculator. 1.0054 equals 1 plus r over 12. I need to subtract 1. So I get r over 12 equals 0.0054. And finally multiply by 12. So my r is 0.065. Remember, we need to turn that into an interest rate, so I need to multiply it by 100. So it's 6.5%. Okay, that is it for 4.2. If you have any questions, make sure you send me an email. I'll be back again tomorrow.